When we have a radical equation with more than one root in it, it's important to isolate one root and then square, or take it to whatever power we need to. In this case, because we have square roots, we are going to need to square. That will mean that 5x minus 4 has to equal 7x minus 14. Then we can solve it like normal, get all the x's onto one side. Negative 4 is equal to 2x minus 14. So we'll add 14. 2x is equal to 10 divided by 2, and x equals 5. Now make sure you check it. Plug it back in. Is the square root of 5 times 5 minus 4 equal to the square root of 7 times 5 minus 14? 5 times 5 is 25, minus 4 is 21. Is the square root of 21. I know you're nervous right now because square root of 21 doesn't simplify real nice, but let's finish up the problem anyway. On the right side, we have the square root of 7 times 5, which is 35, minus 14. 35 minus 14 is 21, so we have the square root of 21 is equal to the square root of 21. That is correct, so our solution is x equals 5. In this example, again, we have a square root is equal to square root, so we can just square both sides. And 5x plus 14 is equal to x squared. Now it's quadratic. You got to pay attention to that. We can't combine like terms or anything, so because it's quadratic, the only way to solve it is get to one side equal to 0. So I'm going to have to subtract 5x and subtract 14. Now we can factor this into x and x, and 14 factors into 7 and 2, so we'll need negative 7 plus 2. So for this equation, we'll end up with two solutions, x equals 7 and x equals negative 2. It's important that you check them both. Is the square root of 5 times 7 plus 14 equal to the square root of 7 squared? Well, 35 plus 14 is 49, and on the left side we got the square root of 49. So x equals 7 is a solution. That doesn't necessarily mean that negative 2 is not. We got to check it. So plug it in. Is 5 times negative 2 plus 14 equal to the square root of negative 2 squared? 5 times negative 2 is negative 10, plus 14 is 4. So we have the square root of 4. And on the other side, negative 2 squared is also 4. So it does work out. In this case, we have two solutions. If the equation, again, has a rational exponent, but it's to the 1/2, we can square both sides. Because when we take a power to a power, of course, these ones will cancel, and we'll have x plus 2 is equal to x squared. Again, this is quadratic, so we have to get equal 0. We'll do that by subtracting x and subtracting 2. Now we can factor it into x, and 2 factors into 1 and 2. If I want a negative 1, I need minus 2 plus 1. That gives us two solutions of x equals negative 1 and x equals positive 2. So check them. Is negative 1 plus 2 squared, or not squared, but to the 1/2 power, is that equal to negative 1? Well, remember, 1/2 power means square root of 1. Is the square root of 1 equal to negative 1? No, it's not. So x equals negative 1 is not a solution. That doesn't necessarily mean that x equals 2 is. We have to plug it in. Is 2 plus 2 to the 1/2 equal to 2? Well, 2 plus 2 is 4, and the 1/2 means square root. Is the square root of 4 equal to 2? Yes, it is. So x equals 2 is our solution.